Hi, in this video we will talk about random variable. The random variable is a function. It is not exactly a variable, but is a function defined on the sample space. Right? So before defining random variable, you need a sample space. For example, you have a fair coin and you toss that coin twice. What will be the outcomes? Say if in the first trial you get a head as well as a head in the second trial. So we have written HH. You may have the H, that is a head in the first trial, and a tail in the second trial. So it is HT. A third possibility is in the first trial you get a T, that is tail. In the second trial you may get H, or you get both tails, right? So these are the different possible outcomes when you toss that fair coin twice. So the collection of all the possible outcomes of an experiment is called a sample space. Now mathematically, a sample space is actually a set. So we can write S equal to HH, HT, TH, TT like this. And each element inside that set of sample space we may call sample points, right? So HH is a sample point, HT is also a sample point. Now visually, this is a trial 1 and this is trial 2. And this point is TT. That means in trial 1 we got a tail as well as in trial 2. So we write TT here. But whenever we get a head in trial 1 and we get a tail in trial 2, the point will be here. Here is HH. That means we got a head in trial 1 as well as in trial 2. And here's a point where we get tail in trial 1, but in trial 2 we got head, right? Now, if our interest is on a single head, then we get these 2 points, right? Here is the 1 point and here is the second point, right? So these 2 points are defining a single head, and this collection is called an event. So event is also a set, that is TH and HT, that depends upon our interest. Now this event E is taking the elements from the sample space S. So E is a subset of S, right? So remember that event is a set or a subset of the sample space. Now you go for a trial and you get HT, that is the first trial you get H and the second trial you get T, then HT is the outcome at this moment. So you can say the event has occurred. The same event will occur whenever the first trial will be T and the second trial will be H, right? Now regarding this event, I will have a separate video for details. Now let's concentrate on random variable. Now let's define a random variable on S. So according to your definition, we are defining the random variable, not declaring a random variable. You mind the term define, right? Because it is not a variable actually, it is a function. In case of variable, you declare, but in case of function, you define. Now we define a random variable on S as it is asked in this definition, right? Now our sample space is HH, HT, TH and TT, right? Now we define the function. We give the name of the function as x. I repeat, this x is not a variable, it is a function. So it's a name of a function. And the definition is we count the number of heads of all possible outcomes. Now if you count the head in these possible outcomes or the sample points, what you will get? In HH, you get 2 heads, you write 2. Here you get 1 head, here is 1 head, and here are 0 heads, right? So we can say that this is a range of this HH, HT, TH and TT. Do not say that X is holding 2 or X is holding 1 like that. X is a function. So how it works, this HH is actually mapped to the value 2. The HT is mapped to the value 1. So there is a mapping business going on between the sample space S and these values. It will look something like this. You have this domain, this HH, HT, TH and TT, and you have the codomain here. So you can say that this is a range because all these values are actually mapped by this domain, right? So HH is mapped to 2, HT is mapped to 1, TH is also mapped to 1, and TT is mapped to 0. So this is nothing but a mapping business going on between this sample space and these numerical values. And this mapping is done based on the definition of this random function or the random variable. So you see that it is not a variable that holds some data, it is a mapper between a sample space and some numeric values. Clear? So we fine-tune the definition of random variable, that random variable is a real valued function from a sample space to a real numbers. That means the function assigns a real value to each element of the sample space. It is a property of a function. That means if you call somebody as a function, then you have to involve all of the elements from the domain to the codomain. Now in the codomain, there may be some values which are not involved in the mapping, but in the domain, you have to involve all of the elements, right? So here it is going on like that. So we call that this x is a map or a function. Now mathematically, you can write like this, that x is the name of the function, give a colon and write s is a set of all possible outcomes, and those outcomes all are mapped to the set of real values. This is R, right? Now let us see whether any change goes on in the range of the function if we change the definition of the function. Now we have the function as half of the head count. Now whatever the count of head will be there, we make it half. So here 2h, that is 2 heads are there. The half of 2 heads is 1, so it becomes 1. And here 1 head is there, you make it half, so it becomes 0.5. Here also 0.5 and here is 0. So you see that the range actually changes due to the change in the definition of the random variable. So that is why we are mapping this s over here to a set of real values, right? I hope it's clear to you what a random variable is, and also you have an idea regarding event. If you have any question, then you may write me in the comment box.